welcome. Please enjoy this short readiness video on Azure Cosmos DB. Hi, Deborah. How are you doing today?
Hey, Sanjay. Great to be here.
Great. It's always fun to talk to you. So what are you going to do, first of all, about your role at Microsoft?
Great. So my name is Deborah, and I'm a program manager on the Cosmos DB team. We're focused on the developer experience. So this covers the SDK, portal, and notebooks experience.
I see. So what are you going to cover today?
Today we're going to be covering partitioning, which is one of the core topics that you really need to know to be successful when you're new to Cosmos DB for the first time, along with data modeling, which Thomas presented. So today we really cover the basics and fundamentals of partitioning, why it's so important to get good scale and good cost and performance in Cosmos DB, and how choosing the right partition key, whether it's for a read-heavy or write-heavy workload, has a huge impact on really the success of your workload.
Awesome. Let's get started then.
Great. So we'll do some fundamentals, but before we do that, I really want to talk about, before we get how to partition, why do we partition in the first place?
Yes.
There's a one-word answer, which is scale. Right. So modern applications, modern workloads, your data really can't fit on one machine. And even if it could, scaling that is a nightmare because you have to keep buying bigger and better machine and keep upgrading it. In contrast, instead of this old scale up model, what Cosmos DB does is it scales out. So we do horizontal scaling, which means all of your data, we take it and put it among a smaller number of physical machines. So each machine is responsible for a subset of the data. So kind of example here, we have a bunch of people for different product teams, Cosmos DB, Postgres, and each of us is responsible for a certain part of the product. And that way, like in partitioning, each machine is responsible for a subset of the data.
I see. Okay. So, in a retail example, you would think, you have billions of rows, then you would partition that, across different machines in a way.
Yeah.
Okay.
Yeah, and one common question we get is, partitioning is really important. When does it become super critical? We find for customers, if you have like a smaller workload, like 50 GB, 50,000 RUs of scale or less, then still follow the best practices, but you won't really see the true impact until you get to a terabyte of data or hundreds and thousands of physical partitions, like some of our largest customers.
I see. So then, how do you think about the keys, the partitioning keys? I think that's the most important decision, right?
Yeah. So when it comes to partition key, before you can even choose it, and I'll show some demos of what goes wrong when you choose a good one and bad one. There's some fundamentals that you should know. So the first definition, and I promise there's only two definitions. So the first one is logical partition, which means all the data of the same partition key is in the same logical partition. So if we took everyone who presented today and partitioned us by the product group, I'm on Cosmos DB, Thomas is on Cosmos DB, folks are on Postgres. All the folks, myself and other people on my team who have the Cosmos DB product group as their partition key value for product team are in the same logical partition. So all our data is kind of grouped together. Same with Postgres and any other product. In contrast, a physical partition is an actual SSD-backed piece of compute and hardware and storage that stores the data. So we take all of the logical partitions and distribute them among a smaller number of physical partitions. From the user's perspective, you just define one partition key per container.
All right, so if I have 1 million logical partitions, do I have that many 1 million partitions for physical as well? Then?
Yeah, that's a really good common question we get from people who are new to this, because one of the best practices later you'll see is to have really high cardinality, many distinct values. So having 1 million logical partitions is actually good. But then you're like, oh, are you going to provision 1 million machines? That sounds really expensive. So the answer is no. What we do is we take all the logical partitions, whether you have 10 or 1 million, and partition them on a smaller number of physical machines. And the way we choose the number of physical machines, it's a heuristic based on how big your storage is. So obviously, if you have more storage, you got to have more machines. If you need a lot of RUs, you need more scale, we'll have more machines. But it's definitely, you'll typically have a lot of logical partitions and a smaller number of physical partitions.
I see. All right, let's get going.
Cool. All right, so here, just to make it really visual for those who like to learn visually, here I have a diagram that kind of shows you behind the scenes what's happening in Cosmos DB. I told you all the data is distributed among the physical partitions, but how does Cosmos DB know which machine to put your data on? And that's based on the partition key. So if you look at this diagram, the purple box here, think of it as the physical partition, right, actual storage. The blue boxes are the logical partitions. So for logical partition key, let's say ABC123, you might have multiple documents with that same value. All data with the same logical partition are also in the same physical partition as well. So you have another one, let's say different partition key, it gets hashed and it figures out which machine that it belongs to. And the great thing for customers is that as your data size increases or as you need more scale, we'll automatically add more partitions for you. So you don't have to worry about adding more data or physically or manually sharding the data yourself.
Wow, fantastic.
Okay.
So can you do a demo?
Yeah. Oh. So that's great. So let's now get into the demo. We have really kind of two kind of key workloads we see. One is for read-heavy workloads. So let's take a look at how we can choose a good partition key for a read-heavy workload and what might go wrong if we don't choose a good partition key. So here are some data, and it's just product reviews that users have written for a retail website. So here's a sample one. Someone said that they reviewed a fleece jacket, right? And we have a username. And in this workload, a common thing you'd want to do is show all the reviews written by a user.
What's the scenario here?
Yeah, so this is a retail scenario where you're buying things on a site, and users are also writing product reviews.
Okay.
Yep.
Got it.
So you imagine you log into this website and you see, okay, here's all the reviews written by this one person, and which would be a very simple SQL query.
Okay.
So let's actually go ahead and write that query ourselves. So let's say select star from C, where c.username equals, just pick this one, Kurt28. We'll run the query and see we get around 881 results. And query stats, we see this query consumed around 123 RUs to return this many. So if we wanted to run this query 100 times a second, that's almost 12,000 RUs per second, which is a lot, right? 123 RUs for one query, especially a very common one, is going to be kind of expensive. So the first thing you want to do, as you can probably guess, is check your partitioning strategy. By the way, I should mention that this scenario is read-heavy, because if you think about a retail website, people read a lot more product reviews than they write product reviews, right? So you want to optimize the cost of your queries and key value lookups. So here we see we've partitioned. Let's take a look. Inside settings, partition by ID, right? But if you look at the query, we're filtering by username.
Yes.
So what we're actually doing here is, remember that purple box diagram I showed you? We're actually going to every single physical partition, spending 1 or 2 RUs to check the index and see, do you have this data for username? Do you have this data? Do you have this data? Which, if you have a small kind of workload, checking 5 partitions for data, not a big deal. But if you have hundreds and thousands of partitions, hundreds and terabytes of data, that overhead is really going to add up. So what we can do instead is we want to choose a partition key that can be used as the filter in most of our queries. Most of our queries are going to filter by username in this retail website. So here I have the same collection, same exact data. Only difference is I've now partitioned by username.
Okay.
So let's run the same query here.
Yeah, basically reviews by a user, right? That's what you're doing.
Yep. All right, and let's see how many RUs is consumed. Okay, and this one only consumed 40 RUs.
Instead of?
120, right? So this same query on V1, 123, and then V2, V2, 40.
That's a big difference.
That's a huge difference, right? Yes. If I wanted to run this query, let's say 100 times a second, this one would only need, let's say 4,000 RUs versus 12,000 RUs, which, as you know, is 3 times cheaper, also in cost, like monetary cost. So you really see how for the same data, same workload, choosing the right partition key makes a huge difference in that performance.
Thank you for that great example, actually.
Yeah. And by the way, this advice for a read-heavy workload also applies to anything read-heavy. So user profiles, product reviews, product catalog, common things, just partition by product ID, user ID, etc.
So besides that, of course, RUs, what else could go wrong if you choose a bad key?
So RUs and definitely latency. So sometimes when people say, oh, my query seems to be going kind of slow, RUs and that are kind of correlated. If you're taking a lot of time to check each partition, that's adding more time. So those are common symptoms. You should check your partition key first and make sure you're able to use that as the filter.
I see. And anything else in terms of IoT scenarios?
Yeah, so that's actually the next one. And when we see customer workloads, they're typically either read-heavy, kind of like that retail website, retail scenario, or write-heavy. Write-heavy means you've got a ton of data coming to Cosmos DB at once. Examples like IoT, telemetry. IoT, you might have many different devices pushing data 1 time a second, even multiple times a second. So you're really pushing lots of data in at once.
So imagine a scenario like retail store. Customers are coming in. We have IoT sensors in the store. In real time, people people that we're sensing, that's what the data could be, right?
Yeah, it could be that. It could be vehicles on a road. It could be devices in a factory. It could even be, it doesn't have to be hardware. It could even be users on a website. You're just, tracking everything that they click.
I see. The point is data is coming in so fast.
So what I've done here, switching over to my VM, is I just want to demo a scenario and simulate a really write-heavy workload on Cosmos DB and show what happens when you choose a good partition key and a bad partition key.
Okay.
So the scenario I've chosen today is vehicle telemetry, like IoT data, but really it could be any of those scenarios we mentioned.
So here you're like a car having lots of sensors sending information.
Okay. Yeah, and you can see we've got some information like event name, description, vehicle ID number, and timestamp, date, region, and any of these could potentially be a partition key. Right, so let's see what happens. Let's just choose a few and measure the performance and see what we get. To simulate a write-heavy workload, I've created two collections here, one partitioned by date and one partitioned by vehicle ID number and date. Okay. And in each one of these, I've provisioned 50,000 RUs, which, there's a pretty small document, so we should be able to get 50,000 RUs worth of writes per second, which is around 10,000-ish writes per second, assuming 7 RUs per write. So let's actually run this. I have the bulk executor library, which is optimized for sending lots of data at once. So we're just going to simulate having a lot of data in Cosmos DB. Now, one common thing you might want to do is, okay, let's partition by date, right? Because we query by on it a lot, and let's see what happens.
Yes.
So we're going to run it and time how long it takes to do batches of 10,000 records and how many RUs we were effectively able to get. Now, if you think about date, what do you think might go wrong, right? Because
in a day, multiple times, and it could be an interesting pattern across days too.
Yeah, and especially because
like a heavy sale happening on one day, or lots of cars.
Yeah, if you think about it, even just a regular day, right? You have a lot of cars on the road, and they're all pushing date, and today's date is all going to be the same for every vehicle. Yeah. So all of them are going to have the same partition key value, which means they're all getting hashed to the same machine. So they're all hammering that one machine, and all the other machines you have, which can serve requests, are not getting any requests, which means they're not really fully utilizing the RUs, since each physical partition has this equal amount of the total RUs, right? So that is what we call the hot partition problem. As you can see here, we finished, but we only got effective RUs of around 7,000 RUs per second, even though we provisioned 50,000. Yes. And the reason is we had a very low cardinality partition key to the point there's only one distinct or unique value for date, which is I'm generating today's date.
Okay.
So in contrast, what you'll probably want to do for write-heavy workloads is choose something with high cardinality or high number of distinct values.
Okay. Like VIN number?
Yeah, exactly like VIN number. In our case, we're actually going to make it even a bit more distinct. We're going to have VIN underscore the current date.
Okay.
And the reason we do that is just for IoT workloads that are extremely write-heavy. Cosmos DB has a 10 GB constraint on logical partitions key values. So if you have one vehicle ID number, let's say 123, you might actually fill up 10 GB of data for that 123 if you're writing, let's say 10 documents a second, right, for an entire year. So by making the synthetic key concatenating with date, we're able to get more granularity to not hit that 10 GB limit.
Okay.
So let's run this and see how fast it goes. And let's see, sorry, date. Okay, and wow, that finished in less than 5 seconds. And if I run this a few more times, let's run it again, I'm going to slowly get up closer to 50,000 RUs per second. Yeah, so kind of like that closer. Yeah, exactly. Now we ran it very, very fast, but it was the same data as being written, just all we did was change the partition key.
That's awesome. Right. Thank you so much.
Yeah.
Any other closing thoughts?
Yeah, let me just put this here. These is kind of the scenarios and the best practices for write-heavy workloads. Closing thought is really, if you're starting out with Cosmos DB, you want to master data modeling, partitioning, and of course later RUs. And it's a really fundamental concept to being successful with Cosmos DB.
Fantastic. Thank you so much. It's always fun talking to you.
All right, thanks a lot, Sanjay.
Thanks for watching this short Azure Readiness video.